Hello there, it's Luke, and we're still discussing haemostasis and coagulation, but in this tutorial we're going to focus on the formation of fibrin. We're going to look at thrombin, the actions of thrombin, and how thrombin comes about, and we're also going to talk very briefly about something called clot retraction. So these are all key parts of the clotting cascade and haemostasis. So as you may have watched the previous tutorials, and we've done something called primary haemostasis, which is the formation of a platelet plug. And we can see that down here, all these spiky little platelets clumped together with this sort of weak but good enough repair of the blood vessel, which is preventing blood from pouring out of our damaged blood vessel. And what we want to do is to stabilize that with a mesh made of fibrin. And how we get to this point is that we take fibrinogen, which is the inactive form of fibrin, which is soluble and has been floating around in the blood, and we want to activate that and turn it into its active form, which is fibrin, which is insoluble, and out of which we can make these fibrin strands, which then become a mesh, which then supports the clots and give it its strength and stability. And the enzyme that brings about that reaction is called thrombin. And what thrombin does is it's a protease. It breaks down the fibrinogen protein, takes away this sort of little lock, if you like, and gives us this active version of factor 1, so factor 1a, which is fibrin. And what fibrin does is it will join other bits of fibrin to make a fibrin strand. And sort of moving on again, another thing that the thrombin does is to activate platelets, and that will become important. So because an activated platelet will express something called glycoprotein. Sorry, there's a spelling error there. There should be an E before an I. Glycoprotein 2A3B, which acts as a sort of glue or a site for the fibrin strands to stick to. And so you get lots of these platelets, these activated platelets, expressing this glycoprotein, which then glues to the fibrin strand. And that combination gives us our fibrin mesh, which is glued onto the platelet plug, which is then a sort of much stronger structure. It's now becoming a clot. Now, one of the jobs of thrombin, this very busy clotting factor, is to convert 13 to 13A. And helpfully, 13 is also called fibrin stabilizing factor. And it's a very similar sort of reaction. So thrombin will be a protease. It will chop off the bit that we don't need from factor 13, giving us our active 13. And it's difficult to see actually on this diagram. I apologise for that, but you can just see these little orange bits of activated factor 13, which is stabilising the clot. And this combination of thrombin activating fibrin and activating factor 13, and therefore both of those things stabilising the platelet plug and turn it into a clot, is what it would be referred to in the classical way of looking at coagulation as the common pathway. Now, as we've said, thrombin converts fibrinogen to fibrin, and we need a lot of thrombin because we need a lot of fibrin because we want to make a lot of fibrin strands. And you may recall from a couple of tutorials ago, we talked about the tissue factor pathway, or extrinsic pathway for stimulating the clotting cascade, and it acts very quickly, acts within seconds. So as soon as a blood vessel is injured, tissue factor is exposed to factor 7. That sets off a little cascade which gives us thrombin. Unfortunately, it only produces very little thrombin. It gets switched off really quickly, this pathway. So we have this problem. We've only made a really tiny amount of thrombin, which has activated a few platelets, but not really done a great deal else. How we get around that is that thrombin uses lots of what we call positive feedback loops. So there's some thrombin it sets off an action which makes more thrombin, which sets off an action which makes more thrombin. We've got a positive feedback. And I'm just going to not talk in depth, but sort of take you through a few of those reactions. So here we've got thrombin activating 5 and 10, which then activate prothrombin to thrombin. So it's a very quick one. We've got 8 and 9, which are activated by thrombin, which activate 10, which then activate prothrombin to thrombin. So we're making more that way. And then we've got a slightly more convoluted one, which the more sort of eagle-eyed people will note looks very much like the intrinsic pathway, where we've got 11, 9 and 10 initially being sort of activated by thrombin at the top, and we're ending up with even more thrombin at the bottom here. So we've got 3 or 4 different sort of cascades all setting off, starting with an activated bit of thrombin from that tissue factor pathway, and ending up with lots more thrombin to interact with lots more fibrin. And we call this process amplification. So all these different mechanisms and all these different reactions that start with thrombin and end with even more thrombin, we refer to as amplification. I'm going to give you another example of the same thing. So you'll recall that we said that thrombin activates platelets, and one of the things that an activated platelet does is express phospholipids and a little bit of calcium on the surface, and that provides somewhere for clotting factors to work together to do their reactions, to sort of be proteases and activate other clotting factors. So we've said that thrombin activates platelets, and as a consequence of that, more thrombin is produced. And if we look at a different group of enzymes that sort of interact with the phospholipids on an activated platelet, more thrombin is produced. And more thrombin is produced if we look at a different pathway, or not pathway rather, but a different set of pair rather of clotting factors. So thrombin will set in motion a lot of different reactions which then give us more thrombin. And we need loads of thrombin because we're going to use loads of fibrin to make those clots. And here we go. So yeah, thrombin activates platelets. So just to sum that up, you can see that we've got this cycle, this positive feedback cycle, where we've got thrombin activation, which activates platelets, activates other clotting factors, so we get more thrombin because we need lots of it. And that's just saying what I've just said. Now, I'm going to talk very briefly about something called clot retraction, but before I get there, I'm just going to note that in amongst all of this, so we've got our platelet plug, we've got our bits of fibrin, we've got our factor 13 that's sort of shoring everything up. You will get white blood cells and a lot of red blood cells that will get tangled up in all of this, and they will sort of lend, again, more bulk and more stability to that clot that's forming. Yeah, and so we've got this reinforced clot that's got other bits of sort of red cells and bits of debris and all sorts of things trapped within it. Now, your platelets are responsible for something called clot retraction, and what that means is that within the platelets they've got, similar to your muscle fibres, actin and myosin proteins that can pull together, and that will pull the clot nice and tight and make it more stable, which is good, but also squeeze out any liquid, any plasma or water that's trapped within that clot, and sort of dry it out a bit and help improve the stability of the clot, and also bring all those sort of clotting factors and the surface of the plates, it's all close together. So we've got this really stable clot that's got lots of these sort of enzymatic processes all going on, which is a good thing. So in summary, we've covered a lot of ground there. You'll recall that thrombin converts fibrinogen to fibrin, and that forms the mesh that supports the platelet plug and turns it into a clot. Now, we need lots of thrombin, but there's only a little bit of thrombin produced by the tissue factor pathway, which is the extrinsic factor, which is very, very fast and occurs when you have injury to the blood vessel. But like I say, it only produces a very small amount of thrombin. So thrombin is able to activate a series of different processes that all occur around the same time, that whereby you have a bit of thrombin, and through those processes you end up with more thrombin, and that triggers more processes, we end up with more thrombin, and so you've got this positive feedback occurring. And just right at the end there, we discussed how one of the many jobs of platelets is to do something called clot retraction, where they just pull everything a little bit tighter together, expel any fluid that's within the clot, and sort of bring it more stability. That's the end of that tutorial. Thank you very much for listening.